Welcome to the very first podcast of Quant Insider. Today we have Dr. Ernie P. Chan with us, who is a well-known figure in the industry, who has been speaker at many conferences. Ernie holds a PhD from Cornell in physics, and he later transitioned into quant. He has quite an unconventional start to the quant. He joined IBM research in their human intelligence team, and then later worked for Morgan Stanley, many hedge funds, and prop desk. And he also founded QTS Capital Management, which is a CTA. In this podcast with Ernie, we discuss machine learning for trading. We discuss about AI agents and how it will affect the quant finance industry. We also discussed about his firm PredictNow.ai, what does he do, what the firm does. So yeah, let's start with the questions which we have with for Ernie. See you there. So Ernie, can you tell me like you did a PhD from Cornell and then you worked with IBM research in their human intelligence team, right? And what made you shift from physics and then from IBM job to a quant job? Like what led you to the transition?
Yes, it's it's interesting because and I was quite happy in the language modern group at IBM doing things that are similar to what OpenAI is doing today, except with unfortunately a 30-year-old older technology. At that time, computers are much slower, and so we weren't able to train a large neural network for the stuff we do. However, a few of the managers, senior researchers that are quite well known in this area, suddenly left the group and joined a hedge fund. And they recruited a number of the senior people as well in our group. So I was very curious how what we do. At that time I know nothing about finance. I didn't even understand what shorting is. How can you
Yeah.
sell a stock without owning it? I could not understand those. But they were, telling us after they joined the firm, how amazing it is. And it turns out that they made the right decision because two of these senior managers became the co-CEO of that fund, which is called Renaissance Technologies.
Oh.
And it became a very famous fund. And they became very, very rich. And so I was also curious how what we do in language modeling has any relevance to finance. So I decided to try my luck and see if there's opportunities in finance as well. So it turns out that Morgan Stanley at that time also started a AI lab, not only concerning trading but all aspects of the investment bank. And so I joined that group later on, and that started my introduction to finance. Interestingly, after 6 months at Morgan Stanley, um, the chief customer of that group, which is the head of the equity trading desk in Morgan Stanley, decided to quit and become global head of equity from at Deutsche Bank. And so our group became like lack of a big customer. So half the people decided to quit also and join another firm called Credit Suisse. And so I followed them and then started to do research in trading models and other stuff. And that is how I started my finance career.
Okay. So I think you worked with Robert Mercer, I guess, from Rentec when you mean like he left IBM, I guess.
Yes, my colleagues left IBM for Quantech. I was not invited. I was a very junior
Okay,
researcher at that
okay.
time. So yeah,
Yeah,
but
actually, how much I remember, Robert Mercer was also in IBM before, so it just clicked when you said your team left.
yes, Robert Mercer was the manager of our group. I
Okay,
never met him because he left just before I joined.
okay, got it. Also, how do you how do you feel that your physics background helped you a lot in quant? Like, how did this help you in transitioning, also in developing your quant career?
Well, I think that really all the quantitative disciplines are helpful background for a quant career, whether you are in electrical engineering or physics or mathematics or computer science or in operations research. They all essentially provide the same mathematical and computational background for a successful career in quant. So it's not just physics. Um, so in physics, of course, we are taught to really use the tool of mathematics to apply to any problem. There's no problem that we feel is beyond the reach of our techniques in mathematics. So that gives you the confidence to really get into a new field.
Got. Also, can you talk about like what does Predict AI do? Like, what is basically its main operations and everything?
Yeah, PredictNow.ai is sort of an outgrowth of the quant fund that I started called
Okay.
QTS Capital. So, despite my background in machine learning, we had a hard time initially finding ways to apply AI to trading because every time we train a model
Yeah.
on past data, it performed excellently in backtest and seldom perform well out of sample. And we finally figure out, together with many people in the community, figure out that, because of the low, signal to noise ratio in the financial market, most of what the machine can learn, if you directly apply it to markets, is that you are learning noise that do not repeat itself, or you are learning opportunities so obvious that everybody already have found it and have arbitraged away that opportunity. So the but towards around 2020 or 2019, learning from the giants such as Marcus Lopez Prado and other writers, we also started to experiment using AI not for directly generating trading signals, but for risk management. That is to say, computing the probability that your trade is going to be profitable, and also for computing for capital allocation, optimal portfolio allocation. These two applications in AI are not subject to arbitrage. That is because no one but yourself know your trading strategy. So, the fact that you can learn whether your trading strategy is going to be profitable or not is really your private knowledge. You are using private data essentially in training your model. No one else can use the same data. And even if they use the same data, they can't use it to arbitrage it because they don't know your strategy. They don't know whether you're long or short index or stock or not, whatnot. They only know that your strategy is going to lose money tomorrow. So what? What can you do about it? You don't run the strategy. But for the person that run the strategy, like yourself, you say, well, if the strategy is likely to lose money tomorrow, maybe I shouldn't trade the strategy tomorrow. So that will help you. That's the risk management aspect of AI that cannot be arbitraged away, and that look, Professor Lopez Bravo call it meta labeling, and we call it corrective AI. And we applied to our fund. It was very fruitful, actually. We were able to generate stellar returns during the COVID era and so forth. And so we decided that, well, that application of AI is somewhat subtle and it's not something that every hedge fund has access to. So we decided to spin out the technology to a different firm and commercialize it for other asset managers and financial institutions to use. So today, we're continuing on that mission, really, mainly providing this technology to enterprise financial services firm for risk management and portfolio optimization that is adaptive really to the market environment and the economic environment.
Okay. So I was recently you're reading a paper of conditional portfolio optimization, which you published few like recently, right? So can you just elaborate on the CPO, like conditional portfolio optimization, the main crux of the paper for our audience?
For sure.
Yeah.
So, there are many traditional portfolio optimization techniques, such as, one is Markowitz mean variance optimization. Basically, you uh, uh, look at the covariance matrix of returns and then compute the allocation that would minimize, that would maximize the Sharpe ratio. Basically maximize the return subject to constant variance, or minimize the variance subject to constant return, one of the others. So another common optimization method is risk parity optimization. That's very trivial. It's basically you allocate based on the inverse volatility of each of the component of the portfolio. But the common theme of all these traditional optimization methods is that they are not, they are looking backward. That's number one. They expect that whatever was optimal in the past is optimal in the future. And secondly, they are not dependent on the market and the economic environment. So all the inputs are basically prices or returns, right? So, well, obviously that is not really close to reality. In reality, what was optimal in the past is not necessarily optimal in the future, may not even be optimal in the present. Maybe we don't want to predict the future. At least we want to be relevant to the present, and there's no such guarantee. And also, it is obvious that the market and the economic environment would affect the optimal solution. So, for example, it might be the case that overall, value stock outperforms growth stock maybe over 30, 40 years period. And but there are some regime where, let's say, with an low interest rate environment, the Fed may be flooding the market with money. In those regimes, it may be the case that growth stock will outperform value stock. So why would you allocate money irrespective of, let's say, interest rate? Why would you allocate capital to stock irrespective of whether there's inflation or whether there's the oil price is high and low? Well, what we do is that we apply machine learning to this problem, where we want to say, well, under the current environment, and this environment is measured by like 600 plus variables, right? Variables such as market volatility, implied volatility, oil price, energy, bond prices, or whatever you can think of, just globally. We don't know which variable is important or not, so you take a maximalist view. And then you say, well, given this set of variables, what was the portfolio that is the most optimal in the past in a similar environment? Maybe you can say, oh, maybe in 1996, who knows? The environment is the most similar to the current day. And in those days, you should allocate more money to oil stocks rather than to tech stocks. That's a hypothetical. That's so basically, using these kind of external variables, we can rank different capital allocation and find out under that kind of regime, what is the best allocation to your portfolio? What components should get more or less capital? And that, of course, the top rank portfolio will be the optimal portfolio. Now, the difference with the traditional method is beyond the fact that it is now taking into account the regime or the environment. It is that it is less sensitive to the inputs, because in the traditional optimization, there's a study which showed that if you have a slight error in your expected return. Let's say you're trying to allocate to U.S. equity, to European equity, to Japanese equity. Let's say just 3 or 4 different country allocation, and your expectation of the U.S. equity market is off by, let's say, hey, 2%, 3%. All of a sudden, it can change your allocation drastically from long U.S. equity to short U.S. equity. It's extremely sensitive to this expected return, if you're using the market risk framework. And because of this sensitivity, it becomes quite useless, because of course you can't really predict the return of a US equity to any precision. Most often people can't even get the sign wrong,
Yeah,
not to mention the magnitude.
yeah.
But in our method, it is completely insensitive. Because why? Because it is using ranking rather than predicting. It does not have to predict precisely, oh, the US equity is going to go 12% up and Japanese is going to be 2% and whatever. It doesn't require that. It is trying to rank which portfolio is likely to be better. It is therefore very tolerant. Maybe you got even the sign wrong. It's very similar to statistical arbitrage. Many statistical arbitrage model rank stocks, right? They are not trying to predict, oh, Microsoft is going to be exactly 12% return next year. Meanwhile, Google is only 11.2%. Forget it. If you have to make that kind of precise prediction of return, nobody can make money in statistical arbitrage. All they care is that, oh, Microsoft is going to outperform Google. That's all they care. And then you long Microsoft and short Google, and you're profitable. Maybe both of them lose money. Maybe both of them are negative. But as long as Microsoft outperformed Google, you're profitable. So we apply the same point of view to optimization. We don't need to be to compute precisely what different allocation, uh, different components returns are in the portfolio. All we care is that overall, we believe that this allocation is better than that allocation and is better than the third allocation. And that is enough to compute a portfolio that is very robust with respect to the inputs and with respect to the predictive returns. So that's the what we call the CPO method.
So basically, we are trying to get the best portfolio based on current regime and by analyzing the historical data, like historical regimes, and as based on historical regime, considering these variables, macroeconomic, commodities, and everything, which portfolio will be best? We rank those, and based on that, we
Yes,
create the portfolio, right?
that's right.
Yeah.
Exactly.
Okay. And can we work something similar if I want to build a regime switching model based on for volatility? How, if you have any idea how we can implement this, if you want to build a regime switching or something similar for actually identifying if we are in high vol or low vol regimes for option markets?
Well, if you only care about predicting the probability of a high fall and low fall regime is actually simpler than our optimization method, right?
Okay.
Because it's
Okay.
just a supervised learning method. So obviously you can use the same set of 600 plus features as an input, and then use that to decide, and train it on the historical high or low fall regime. You have to label this regime as high fall, this regime is low fall, and then hopefully these 600 variable can predict, let's say using random forest or using neural network, uh, whether they are high or low fall, and that's a very simple application of supervised learning. And many people have done that. I mean, actually, that was a project that was assigned to us in Morgan Stanley some 30 years ago. So
Yeah,
people have been,
even because even we are working on similar thing, that's why I asked you because we are also
yeah,
working on regime switching model for walls. So
yeah,
I thought I will just ask you this.
yep, yeah, yeah. I
Okay.
mean, almost every other person we consult for ask for the same.
Okay. Now I will ask you few series of questions on particularly like building like a trading strategy based on ML. So it will be like series of questions. So
Mhm.
is it fine? We can start.
Please.
Yeah, yeah. So how do you typically structure your data pipeline for ML based strategies, like covering everything from data ingestion to cleaning and addressing missing noisy points? And then like what is basically a whole pipeline for that, for building a data pipeline before starting with the feature engineering?
That is a very, very good question. And it has a lot of nuance and pitfalls
Yeah,
hiding in there. So a lot of people would ask me, "Oh, how do you clean the data?"
yeah,
And I tell them, "You are not supposed to clean the data because the data is supposed to reflect reality. Let's say you have a data feed that misses every fifth tick, or that has an error every four ticks. Instead of showing Google at $100 every five tick, it add $5 to it. Well, you say, oh well, that's wrong. That data feed. Let's correct, get rid of those wrong tick. Well, the problem is in live trading, you are still using that 40 data feed. So you're going to get exactly this problem that you see in your historical data. By cleaning the historical data, you're actually distorting reality. So when you process data, the key is you want the data to reflect a live inference situation or live trading situation. It is not to conform this data into some ideal platonic ideal state where it's free of all noise and it's all beautiful. That is not what you will see in reality in live trading. And so you backtest on that ideal data, you get an ideal result, which is completely different from the actual result you get from trading. So the key to getting the right data is to ensure that the data is reflect reality. To be more precise, more concrete, it means that it's point in time. So the data should not be revised afterwards. You cannot say, well, even though the data show that Google is $5 higher, but I know that that was the wrong take after the fact. Let me get rid of it and just subtract 5. You cannot do that. That is called revising the data, and it's not point in time, and that is actually not good. It's not a good thing. You want to restore the data to its point in time state with no revision, no cleaning. That is what you should be using for backtesting. Another kind of data that violate this principle of point in time or restoring to reality is survivorship bias. So oftentimes you have stocks that disappear, right? And
Yeah.
and and if you say, well, the stock has disappeared, let's get rid of it from the data. Well, that's bad because those stocks that disappear might be the one that will make you bankrupt if you are long 100% of them, right? So this so-called restoring to reality or point in time is a very subtle, there are places where you didn't expect it and they will creep in. For example, there might be a strategy that trade earnings announcement. Let's say you have the strategy to say, well, I think that whenever the stock is at high watermark just before the earning announcement, it's I'm going to short it, and then I will cover it when the announcement is over. So let's say announcement is at 4:01 today. I will short it at 4 o'clock, if it is at high water mark, and then tomorrow morning I will buy back. You back test this strategy and it makes money. Let's say. Well, but wait a minute. How do you know when this short stock is going to announce earning? Oh, you say no problem. Go to Yahoo calendar, earning calendar historically. It tells you that, oh, this stock supposed to, Microsoft is going to announce earning today after close, Apple is going to announce tomorrow after close. I know all of that. I backtest it with those historical data from Yahoo, right? Well, unfortunately, most earning calendar, historical earning calendar, especially from Yahoo and those free stuff, they have revised earnings calendar. That is to say, sometimes some companies say, well, I expect it to announce after close today, but I decide not to. I delay the announcement by 1 week. If you look at Yahoo Calendar, you will find that that announcement is now a week later. That's the actual announcement. It's computed to about. They only recorded the actual, but they didn't compute the point in time expected announcement time, which is 1 week ago. And but when you start to live trade, you do not know that suddenly Google is going to announce that they will cancel the announcement, postpone it 1 week. So you would have shorted it at the close, and only to find out, oh, by the way, sorry guys, we are not announcing today. Wait for a week. Well, that is the problem if you're using historical data that didn't um, record the expected announcement date. It only record the actual announcement date. So it is not point in time. That earnings announcement calendar is not point in time. It's a revised calendar. And again, that will produce backtest result that is completely unrealistic compared to what you see live trading. So you can see that in many cases, the key of data processing is to make sure that the data is in a form where you will actually see them in in real time, not after the fact. No look ahead bias, no survivorship bias, and so forth.
Okay. Yeah. So another question is on feature engineering. So while building you can say a factor model or factor based strategy. So what are the things that one should keep in mind while basically building those features?
Well, I think that the only thing that really need to be aware of is stationarity of the feature. So a lot of, if you look at some naive machine learning code applied to stock trading, you can find many of them. They say, oh, let's have the prices of various stocks as an input to neural network. Obviously, that's not going to work because stock prices are not stationary. So if you use the price of Tesla, maybe not 8 years ago as an input to train a model, well, today you will never see those prices of Tesla again. It has gone up, I don't know, 10 times, 100 times, who knows how many times it has. So so a lot of times when you apply feature engineering, the first thing to do is to make sure that you have to process the input into a stationary time series. You could, for example, perform first differences, percent differences, and so forth, or fractional differentiation and whatnot. So that's the very first step to do. Another thing that you need to do is, basically normalization. So if you are interested in, for example, create a trading model for any stocks in the S&P 500, and you are intending to use, let's say, earnings as an input, right? It sounds reasonable, right? Oh, high earning stocks, maybe you will learn to buy, and low earning stock is short. But earnings itself is an anonymized quantity. You cannot compare the earnings per share of one stock to another. You can only compare, for example, the earnings yield, the earnings per quarter divided by stock price, for example. So a lot of the raw data on finance cannot be directly used as features. They have to be either made stationary, or they have to be normalized so that you are comparing different instrument factors correctly. So those are the two typical steps that you have to perform.
And what is your take on using alternative data for building features and models?
I'm sorry, what data?
Alternative data, like you have different
Oh,
knowledge.
alternative data.
Yeah.
Yes, yes. No, that's actually uh, much easier nowadays. Of course, you should use it, but and it is actually because of the availability of large language models, it become much easier. Because before you have to rely on a third party to say, oh, the earning announcement is this, and the CEO have make some earning calls. This is a transcript, and what is the sentiment of this transcript? Well, you have to rely on a third party. The problem with allowing on third party to create a sentiment score to convert this kind of unstructured data to a numerical format is that they would never tell you what model they use. And you are never sure whether the model is correct or not, and whether it can even be reproduced. Not, correct is maybe too much to ask for, right? We can't say what does correct mean, right? But at least they have to be consistent throughout time. And oftentimes, even that low bar cannot be crossed. A lot of data firms have changed the methodology over time in converting unstructured text to sentiment score, and they didn't tell you that they have changed the methodology. And so whatever you backtest in the past has no bearing on the future because they changed the methodology of computing the score. They don't have to tell you that. It's proprietary. But now, fortunately, you can use any large language model and process, of course, you need to have the API and process large quantity of this text, at least in a consistent format, um, assuming that you are using a same version of the large language model, right? So language model actually have a version number, so you can use the same version number. And if you want to update it, you have to redo the back test, recompute the sentiment score. But that's okay. At least you know that, hey, with this version of the language model, it produced this sentiment score, and that is much less expensive than before when using alternative data, namely unstructured data.
Got it. Also, how do you approach hyper tuning, like given that we have time series constraints and data limitations?
I'm sorry, what constraint?
Like how do you approach hyperparameter tuning in generally in models, given that we have time series constraints and data limitations?
Yes, I think that a lot of times people just use default hyperparameters for, if you have a large, deep learning network. Um, Otherwise you would have to use one of those packages for hyperparameter optimization like Optuna or so forth. They may use Bayesian optimization and so forth to speed up the hyperparameter optimization. But usually the typical situation is that you would hope that the model is robust enough that you do not need hyperparameter tuning to get good results.
Okay. Generally, slightly off the topic. So, how do you think the surge of there are a lot of talks around generally AI agents coming into the picture, right? So, how do you think it will affect the whole asset management industry and the whole investment trading space in general, as per you?
Well, interesting. We just recently finished a book with a colleague of mine on generative AI and asset management. And during that book, we have tested some of the large language models on tasks such as writing code in for backtests and generating trading strategies, ideas, or reviewing papers, summarizing papers, or converting papers into code. And generally speaking, no, whether you're trying to produce code or whether you're trying to summarize papers or come up with trading strategies, uh, it is not there yet. It requires tremendous amount of human intervention and correction. It can certainly help speed up the process, no question about it, because you don't want to have to write a function to calculate maximum drawdown every time. But or you don't want to start, let's say you want to try a new technique like reinforcement learning. You don't want to have to figure out exactly what program to use and so forth. They can suggest the correct libraries and so forth. So there's no question that it is a productivity enhancement tool. But without extensive guardrails, you would not use that for live trading. You should not use it for live trading. You would use it for tasks that has a high tolerance. For example, you might use it to screen out applicants, job applicants. There are 100 people send a resume to apply to be a quant trader. You don't have time to read 100 resume. You can train an agent to say, oh, well, I select 20. So for human input. Well, if you miss a really good one, too bad, but it's not fatal. Because even if you have you get some kind of assistant to do it, they will have made an error too. So as long as it performs tasks with a similar, that your task is very error tolerant, go ahead. But when you are saying that you want to make a trading decision based on a model that can make you lose $1 million a day, well, you wouldn't trust a program that is a black box and has no guardrails to do so.
Yeah. Also, coming on the applicant part, so we talk to a lot of entry level people who want to get into quant, a lot of undergrad students. Okay, so one thing few people were asking that does the LLMs are going to affect entry level quant flows, particularly on the sell side, because as you know, starting initially 3 to 2 3 years, You don't get to do a lot of research work, but you do a lot of grunt work in like reading old codes, cleaning old codes, going through documentation, working on the others' work, and just trying to improve it as an entry-level quant, probably in sell side start initially 2 3 years. So how do you think it will affect the entry-level quant roles as per you?
Well, I think that um, you would essentially still have to do the same task, except that you are need to be able to scrutinize whether a Gen AI generated program is correct or not. So it's not that you suddenly don't need to learn Python or learn MATLAB or learn C++. You still have to do that because the program, as I said, that the LM spit out, most of the time has bugs in it, or they are not doing exactly what you want to do. So you would need to learn how to debug their code, the code that is generated. You don't have to write it from scratch, but you have to know how to debug it. So in terms of the high level skills, it's pretty much the same. Because if you don't know how to debug it, if you don't learn the language well, you wouldn't know how to debug it. And at the same time, you cannot trust the code that is automatically generated. So it improves the productivity because you don't have to write from scratch, but it does not require less skill. So I think net is beneficial to those smart junior level programmers because they will still be valued as a gatekeeper for this auto-generated code. But of course, if you are a bad programmer to start with, your job won't be needed because A, we don't need you to generate the code from scratch, and B, we don't trust your judgment of whether the code is correct. So why should we need to hire you? Whereas before, a bad programmer might be like ChatGPT. They would be generating the first version of code, and then the second level programmer correct them so that it saves the second level programmer time, right? So yeah, I think that it really put more premium on skills rather than grunt work is what my assessment is. And another aspect, and it's more general, it's not just about quant industry or programming AI IT industry. It is that it put more emphasis on human um, skills, the soft skills like communication skills and management skills, because the technical skills, a lot of it can become very agile and productive and efficient because you don't need to hire many people, but you still need people skill to manage the team to create to get to the goal. So I feel that I have found that and let me tell you a live story. I won't want to name names, but I work with a programmer that is very, very smart, they're in impeccable pedigree from the top engineering school in the US. But the problem with this guy is that I have a hard time. He's not a native speaker, and I have a hard time understanding. Most people have a hard time understanding what he's saying. And also, his style of communication with clients is kind of abrupt. Um, it's not smooth. Okay. So before we would tolerate such a person because hey, this guy can write code, right? What can you expect? And if you don't hire him, you have hired someone else with less quality code, not good. I don't have time to write code for 100 clients, right? So I have to hire. But now, well, I feel myself I'm much better in communicating with clients, and if there's some simple task like you mentioned, create a volatility regime prediction model. Before I would have to have this colleague of mine handle it. Now I say, well, I don't need any help because I can whip up such a code with the help of ChatGPT in an hour, essentially. Make sure that is correct and ship it to the client. So therefore, if your only skill is technical and you do not have the communication and people skill, you are much more likely to be made redundant. That is another aspect of it. But that's true not just in the tech sector, but in general. Whether you are an accountant or lawyer or whatever, your technical knowledge is not enough anymore because a lot of it can be made redundant by AI.
But yeah, yeah, as a lot of, I think, a lot of basic level work will be cut down, and it will actually, people will get a lot of productivity benefit from Gen AI. Like, and even what my view was that the number of headcount required for very entry level jobs in tech as well as in quant will reduce. Like, number of people required for those entry level work will reduce. So
Mm-hmm.
what happens in India is, I will not say, but few of the FANG companies hire a lot of engineers. But as they start as a SDE1 in India, they are doing very basic work, like very basic work as SDE1s. They're getting paid good amount of money, like very good
Mm-hmm.
amount of money as SDE1 in India. And but the thing is, they're doing very basic work, which I think a lot of work can be now like done with Gen AI, like basically the models, and number of people required, like before you required 40 people, now you will only take 20 people will handle the work.
Mm-hmm.
That's what I think. A lot of basic level jobs will actually reduce a number of people required for those, as per my view, what I'm thinking.
Yes, yes, yes.
Yeah. So now back, we can just go back to the strategy and the ML part, I guess. So
Mm-hmm.
yeah. So when we basically do walk forward testing, right, in the model, which you also talked about in your book, the winning trading strategies, I guess. So how do you detect or mitigate overfitting before strategy goes live?
Well, obviously, you wanted to you make sure that first of all there's an out of sample data that you tested on the on which you test your model, and if it works, then you should begin paper trading. During the paper trading period, not only you ensure that there is no operational problem with the model, you also ensure that there is definitely a true out of sample testing, and that also that you test for the transaction costs that might be unexpected. There may be market impact that you are not expected. You can also, a paper trading also really ensure that the live trading model produce result that is the same as your backtest model, because oftentimes you have two different model, two different code, one for live trading, one for backtest, and they actually don't produce the same trade, and that you can only find out when you start paper trading. So there are many things you should test for in paper trading. The fact that the data is not overfitted, the fact that the live trading program is generally the same trace as the backtest program, the fact that transaction cost is properly accounted for and realistic, and so that these are the main. And fourth, that there's no operational bugs, operational difficulties. Sometimes you say, well, I should execute at 3:59:59. Well, too bad. The model would actually take 1 minute to run in live. So, by the time you finish sending all the markets closed already. So, yeah, there's all these issues that you should test for in paper. And then if you pack trade for a period of time and the paper trade for a period of time and it all looks good, all these issues are resolved, then yes, you can put a small amount of money to start live, uh, with live money. But the period of time that you need to paper trade depends on the Sharpe ratio, the backtest Sharpe ratio of the strategy. The higher the Sharpe ratio, the shorter the time you need backtest. So if you are a Sharpe ratio 10 strategy and you paper trade it for 1 month, and indeed every day profitable, that's that's good. You don't have to do much longer. But if your Sharpe ratio is like point 8, well, chances are you have to backtest, I mean, live trading for at least 6 months before you can prove that your live trading strategy, because it's easy to lose money for 3 or 4 months if your Sharpe ratio is point 0.8. So you would need to backtest for a paper trade for much longer time uh, in order to validate your backtest. And exactly how long, I actually had a formula for that in my book, second edition of quantitative trading. It tells you exactly how long you need to do based on the Sharpe ratio. And actually, that was not our original idea. Of course, it's again Professor Lopez de Prado's original research, but we just simplified and quoted it in our book.
Okay. Something just related, very basic question. So, uh, what are the parameters or factors one should consider uh, for basically to understand the strategy should be worth considering or pursuing for the market? Like how what are the things they should look for in the strategy?
Actually, do you mind repeating the question?
Yeah. So what are the parameters or evaluating factors one should look in the strategy before like for deciding that is the strategy worth putting in the market live
Well,
like going
I
live
think
with the
what you meant
strategy?
is what performance metrics you should look at.
Yeah. Performance
Oh,
metric.
yeah. Well, there are typically, I would say three numbers.
Okay.
One, is the common Sharpe ratio,
Yeah.
but Sharpe ratio only really useful for high frequency or mean reverting strategy. When you have a trending
Yeah.
strategy, trend following strategy, the Sharpe ratio is likely to be low. In that case, you would also look at the karma ratio,
Yeah.
and finally the skewness of the strategy. So if a strategy has low Sharpe ratio, it better have a pretty positive skewness that will compensate for low Sharpe ratio. In other words, it might be this strategy only make money once in a while. Most of the time, you lose a small amount of money, but suddenly it will make a lot of money. So that's a typical of trend following strategy. That would show up in the skewness of the return, but it would result in a low Sharpe ratio. So if it has a high skewness, you can tolerate a low Sharpe ratio. But if you have a skewness that is, zero or maybe even slightly negative, you better have a high Sharpe ratio.
Got it.
But in both cases, karma ratio is a good judge. Even for trend following strategy, you don't want a particularly low karma ratio.
Okay. So something very I think a lot of people talk about this probably when we trade mean reversion is one should keep a stop loss or not in mean reversion. That's a very big debate which goes on that one should keep a stop loss while trading a mean reversion strategy or not.
Well, there are two kinds of stop loss. So
Yeah.
if you are saying that it's a catastrophic stop loss, that is reasonable. Let's say I don't want to lose half of my equity.
Yeah.
That makes sense.
Yeah.
But you don't want to set a tight stop loss for mean reversion because the whole point of mean reversion is that you believe that if you are losing money, it actually create more opportunity to enter, right? Because you expect it to mean revert. So if you every time you lose money, you stop out, you basically have no faith in your mean reversion. You think that well, half the time it mean revert, half the time it trend. That's not mean reversion strategy. Mean reversion strategy means most of the time it's mean revert. So you have to assume that it will mean revert. So you cannot set a tight stop loss for mean reversion strategy. It is okay, however, to set a catastrophic stop loss on a rare occasion that indeed your model breaks down, but you don't want to lose all your money.
Also, so before people used to use augmented decay test or in co-integration to you can say for building mean reversion strategy, right? Okay, so do you think that even for statistical arbitrage, people use it? So do you think it is still relevant, or using something like a k-mean clustering is much more relevant in nowadays for building statistical arbitrage, or something like a OU process to build a statistical arbitrage strategy?
Well, ADF test is when you have a time series that truly are stationary for a long
Yeah,
time. Most of the time, mean reversion opportunity is for a short-term
yeah,
phenomenon, in which case, as long as you get the OU test that says that your half-life is short, then you should be able to trade it. You don't have to have a truly stationary time series for that.
okay. Got it. Also, something just so once we generate a signal from a ML model, right? We generate signal or feature. So how do we actually integrate in a portfolio or like in a actual trading?
Um, no, if you find it to be mean version, what's the difficulty of
No, no.
creating?
Apart from the mean version, now like in terms of machine learning, the question is on more like machine learning stuff. So once we have generated a signal using ML, right? Any ML model. So how do you integrate it into an actual trading strategy, especially if you have a multiple ML models running concurrently? Do you use assemble method
Well,
or you use correlation checks to avoid conflict signals?
but if you have multiple training signals or multiple strategies, the question is how to allocate capital to each of them.
Yeah,
And again, it brings us back to the portfolio optimization problem that we started discussing. So we
yeah,
would CPO, and actually a fund in India uses CPO. It's a customer of ours that they produce very good results by allocating capital based on this machine learning algorithm.
okay. Got Also, one more thing, it's not very serious, but if you were active on Twitter recently, so there was a huge debate going on that should one look at VIX as a percentage or as an absolute thing? So, what is your view on that?
Well, to me, fix is always a percentage because it's basically the volatility is a percentage, right? So volatility is standard deviation of returns annualized.
Yeah,
So when you say 15, well, that's 15% volatility, 15% standard deviation of the return. Return itself is a percentage. So and volatility is the standard deviation of return. So it's a percentage also. It's the difference between two percentages, right? Let's say
yeah,
your return is 10% a year and volatility is
yeah,
5%. That means that there's a 1 cent deviation that it could be 15%, and the downwards it could be 5%. So fix is a kind of a volatility. So obviously, it's to me it's obvious that it's a percentage, and it is it can be negative, and it can. So I'm not quite understanding why people don't think that it is a percentage.
No, so basically, people are discussing that. So, if the VIX is on 15, right? So, it moves from 15 to 20. So now how will you consider in your model or a trading that how you will consider incorporate in that? So will you consider that you will take 15 20 minus 15 divided by 15 as a percentage change in the VIX? Or you will just take 15 to 20 as a change?
Yeah, yeah.
Yeah.
No, I think that the absolute difference is fine because
Okay.
that absolute divide by 100 already. So
Yeah.
that is already a percentage. So now, I mean, that is not to say that you cannot compute a percentage of a percentage because that's what VVIX is, right? VVIX
Yeah.
is the volatility index. So there are signals in saying, well, what is the percent move of the volatility index? That is something that you can use as an input as well. So, I don't see that this uh, that one should be dogmatic in saying that you cannot compute the percentage change of a fixed index. I don't think that you should say that there's no signal in it.
Okay. Another thing, again on something on regime, like market regime. So, building. So, what do you think? Uh, uh, if one should approach a problem of change detection when they are building a model for change detection, what should be their approach of build from starting to end? Like, what should be their approach of doing it? Like building a regime switching model for their portfolio or for a short term trades.
Well, for short-term regime switching, it's clearly depend on short-term indicators
Yeah,
such as the order book,
yeah,
uh, fix, and liquidity and whatnot. So no matter whether you're predicting regime change or price directional change or volatility change, it is
yeah.
always a matter of time frame.
Okay,
If you have a long time frame, you use indicators that has a long time frame, such as macroeconomic indicators. If you have a very short time frame, you essentially use order book and prices, uh, inputs. So yeah, it doesn't really matter what you're trying to predict.
okay. Another thing which I was thinking that if we try to actually take return of a one regime and return distribution of another regime, and then we try to understand how the return is changing, and based on that, if we can try to predict the regime change, is if we can work around that, something like that.
I'm sorry, can you repeat?
Sure. So let's say we have two regimes, right? I have a return distribution for one regime, okay? Like I have a certain return distribution for one regime, and then another return distribution for another regime, okay? So what if we use something like KL divergence to find a distance between two probability distribution, and there is one threshold to decide regime shift?
Um, yeah, I think that sounds like a reasonable idea. Worthy of trying.
Worthy of trying. So using
Yeah.
KL divergence to get the
Mhm.
distance between two return distributions, and then we set a threshold and uh, we try to get something out of it. Okay, got it. Yeah, because recently we read a few paper on KL divergence. We thought like how we can incorporate in regime switching. So we also thought
Mhm.
of let's see how it goes.
Yes.
Yeah.
I do have to prepare for another meeting
Okay. Sure. Sure.
shortly. Yes.
Just one question, last question.
Mhm.
Thank you so much for your time. So, what is the most common mistake that newcomers make while applying machine learning, and what is your guidance for them, or what is your uh, basically they should keep in mind while applying ML models in the basically in the market?
Well, I think that it's the same advice that you would tell a programmer. Say, well, you want to learn programming, and then there's all these AI tools. Should you even learn programming, or should you just ask the AI tools to create program for you? And I already answered that actually before. I say, well, of course, you need to learn how to program before you can use the AI tool, because you don't know what the AI tool produces is right or wrong. Similarly with trading, you say, well, should I just train a machine learning model to trade, or should I try out different rules that I believe um, capture what I understand about the market? And the answer is the same. You should definitely try what we call causal models. That is to say, models that are based on your understanding of the market opportunities before you try to use machine learning to capture all these other factors that you don't know about. Because again, you never know whether the machine learning program are capturing phenomenon that already has been arbitraged away, or that they're actually just noise.
Got it. Thank you so much for your time. It was great time discussing with you. So many insights from your side. So I think we can connect. We can have one more discussion later when time permits. So thank you so much for your time.
It's my pleasure. Thank you
Yeah.
for inviting me.